What's up, everybody? Two lessons left. We're going to look at parallel lines today. So here we go. I can identify parallel lines from characteristics in their equations. So we're going to work on that first, and then write the equation of a line when given information about a parallel line. So we're going to show what parallel lines have in common by graphing two separate lines. You can probably guess what's going to happen with these two, but let's go ahead and do it anyway. Negative 3/4 x plus 6. We should be able to do that by now. Go up to 6, down 3, right 4. And there's the first line, the one in red. And let's do the one in, change colors to blue. Let's do the second one. I could use intercepts, except the x-intercept would be 16/6, which is not a good number. So I'm going to transform that equation into slope-intercept form. So I get 8y equals negative 6x plus 16. Divide by 8. Negative 6 divided by 8 is negative 3/4 if you reduce it. 16 divided by 8 is 2. So 2, down 3, right 4. And what do you notice? They're parallel. Okay, now let's look at their equations. That's the key thing that I want you seeing. The equations, the ones in slope-intercept form, because they are in the same form that's easier to compare. What do the two lines have in common? Hopefully you see that they have the same slope. What is different about the two lines? They have different y-intercepts. And that right there is the summary of what makes parallel lines without actually graphing. So two lines have the same slope and different y-intercept, then they are parallel. Without even graphing, I can tell you true or false on that. So we're going to look at that with the next three problems. We're going to look at two equations, identify them as parallel or not. So we're going to look at their slopes and then also their y-intercepts, because the slopes themselves is not enough. You got to have both things. Slopes are the same and the y-intercepts are different. All right, so here we go. The first one, the slope is 2. And the y-intercept is -1. Second one, not ready to go. I got to get y by itself. Not too difficult here because I don't have to divide y by anything. So the slope on this one was -2, and the b value was 3. Now, I have a lot of people who look at this and they say, oh, it's 2 and -2. Those are basically the same. No, they're not. 2 and -2 are different numbers. The slopes are not the same. These are not parallel. Why? Because the slopes are not the same. Okay, so write that down. The slopes are not the same. I'm not going to write it out here because that would just make the video much longer, but I'm saying it. Make sure you write that down. There's not parallel because the slopes are not the same. All right, number 2. Well, the second one this time is in slope-intercept form, so I'm going to go ahead and identify my slope as 5/2. My y-intercept is -4. All right, second one, I need to move, or sorry, the first one. I need to get my y-intercept and slope by getting it in slope-intercept form. So I'm going to do that kind of down here. So subtract 5x, I get -2y equals -5x plus 8. Divided by -2. Negative divided by negative is positive. So positive 5/2x. 8 divided by -2 is -4. So 5/2 is my slope. My b value is -4. Now, a lot of people will look at this and say, oh, they're parallel. Slopes are the same. Look a little further. What else is the same? The b value is the same. These are exactly the same. If you look at the original here, this was line 2. This was line 1. They're exactly the same. Those are not parallel. Those are the same line. Okay, not parallel. The y-intercept is the same as well. That makes it not parallel. So we've had two that were not parallel. You can probably guess that the third one's going to be, but let's just make sure. Subtract 8x, so I get 6y equals negative 8x plus 30. So divide by 6, I get y equals negative 8 over 6, which reduces to negative 4 over 3. Make sure you reduce those always. 30 divided by 6 is 5. So slope of the first one is negative 4/3. Slope of the second one is negative 4 over negative 4/3. Y-intercept for the first one is positive 5. Y-intercept for the second one is negative 5. Those are different. These are parallel. The slopes are the same and the y-intercepts are different. Okay. Now, the next example and the next three examples really is more what you're going to have to do on your test. Okay, so I'm going to go through this kind of slowly at first, and then we'll do a couple more quickly. So we want to write the equation of the line parallel to that line that goes through the point 7, negative 2. What I'm going to do before I do this is I'm going to go down here and show you what we're doing. So parallel to negative 3x plus 4 that goes to the point 7, negative 2. And there, I'll use that graph right there. So negative 3x over 4, or plus 4, negative 3x plus 4, down 3, right 1. This is the line that was given to us. And then 7, negative 2, so 7, negative 2. That is a point that's not on the line, right? It's definitely not on the line. I want to write the equation of the line that goes through that point, but is parallel to this line. So it's going to be something like this. I want the equation of that dotted line. That's what we're doing here. Okay. So let's go down and do it. Step 1, find the slope of the given line. So in that previous, what I just drew up there on the graph, I want the slope of the solid line that was given to me. Okay. Not too hard because it's in slope intercept form. The slope of the given line was negative 3. This is the key step here. Step 2, find the slope of the parallel line. This is using the relationship that we just established. The slope of the parallel line is also negative 3. Now, you might be like, well, why are we doing this if they're the same? They are the same today. Keyword is today. Tomorrow, this step 2 is the vital key step in figuring things out. Today, it's not hard because you're using the exact same slope. Okay. Step 3 is write the equation using the point. You just found the slope. Now we got to use the point to write the equation. And this is point slope form. So y minus the y value is negative 2. The slope was negative 3. And the x value was 7. You can stop there in this problem. So there's a step 4, and I say sometimes, because sometimes I will ask you to transform the equation into slope-intercept form. If I don't, you could stop and say y plus 2. I would want you to change that minus negative to plus 2. Negative 3x minus 7. You can stop there. However, I'm going to go ahead and transform it just to show you and remind you that that is a thing. Negative 3x, negative 3 times negative 7 is positive 21. Subtract 2. I get y equals negative 3x plus 19. And if you would rewind this video and look at when I was graphing this problem, you saw that that dotted line was going to cross way off the graph, and you can see it would. The y-intercept is positive 19. That's not crossing on the graph that I have provided. All right, let's do that a little bit quicker on the back. Write the equation of the line parallel to that line that goes through the point 6, 1. So the first step is find the slope of the given line. So you'll see me do this sometimes. M of the given So that means slope of the given line and its slope, right? So not as easy this time. I got to move this around. I got to subtract 2x divide by -4. And everybody freaks out on this part right here. -2 divided by -4 is 1/2. That's not the freak out part. The freak out part is right here. 11 divided by -4. Oh no, that's not a good number. What am I going to do? Well, keep in mind what you're looking for. I'm looking for the slope of the given line. I don't need the y-intercept of this line. I don't care about that. All I need is that right there. The slope of the given line is 1/2. I don't need the y-intercept of the given line. I need the y-intercept of the parallel line, which is what we're going to do next. Well, not quite next. So the slope of the parallel line is also 1/2 here. And now let's write the equation. So y minus the y coordinate, which is 1, slope x minus the x coordinate, which is 6. Again, leave it like that. Unless I tell you to change it, I'm going to go ahead and change it again just so you can see it. So y minus 1 equals 1/2 x. 1/2 times -6 is -3. Add 1. I get y equals 1/2 x. -3 plus 1 be -2. Okay. Last one is the same question, just shown differently. Kind of what I showed you already with the first example that we did with these. Write the equation of the line parallel to the line shown that goes through the labeled point. So the labeled point's way down here, not on the line. So the first thing we need to do, just like the last two problems, was find the slope of the given line. Good news is here, you can count that. So down 1, 2, 3, 4. So down 4. Right 1, 2, 3, 4, 5, 6. Which does reduce, and I'll go ahead and do that, to -2/3. So then what's the slope of the parallel line? Again, don't just think, oh, this is such a stupid step because they're the same, because tomorrow they will not be the same. But in this case, yes, they are. It's -2/3. Now, this is probably the trickiest part of this whole, when it's like this, make sure you have the right coordinates of the point that's given. -6, -5. Okay, so then y minus the y coordinate equals the parentheses x minus the x coordinate. I'm going to go ahead and simplify. Y minus -5 is y plus 5. X minus -6 is x plus 6. I'm going to go ahead and distribute. Y plus 5 equals -2/3 x. And then -2/3 times 6 is -4. Subtract 5. I get y equals -2/3 x. -4 minus 5 is -9. Real quick before I end this video, from that point, we found the slope was -2/3. Down 2, right 3, I could have found that. Down 2, right 3. Okay, so you could actually count and see that that is -9. That y-intercept, which matches our equation. Okay, we're going to do almost the exact same thing tomorrow, except instead of parallel, we're going to look at perpendicular. So stay tuned and we'll get to that next.